Guys, in advance for this lesson because you're going to hate it. You're going to hate it. We do have a project for this unit. That's a good thing. Which one? Yeah, it is that one actually. The transformation project. The one in the window there was Lane's, but the one on the backboard, the ones on the backboard, all the pictures. Depending on how creative. What were you pointing at? Yeah. It just depends on. Did you help her with it? The penguin, the girl, the Picasso-looking girl. You don't have to be that. I've got some. Yeah, I've got some up there that aren't as extravagant. Yeah, I just saved the ones that. Last semesters, I haven't put them up yet. They're on top of my thing. I haven't had a chance to laminate them and hang them up yet. Yeah. I give extra credit, little bonus points for going above and beyond. And as soon as I say that in an honors class, it's all extra. All right, so this is kind of this. I say a tough unit, but it's not. Nothing's like that quadratic unit. Nothing. So we start with piecewise, and then we're going to move into our function transformation. So it shouldn't be nearly as bad. How many of you have seen something that looked what? I haven't even done anything yet. That tells us that it's a function. That's all it does, is it says it's a function, and the variable in the function is x. That's exactly right. How many of you have seen something like this before? Yeah? Okay, so this is, the name kind of gives away what it's doing and what's happening here. This is a piecewise function, which means it's made up of pieces of other graphs, okay? So it's got a piece of this graph, and what kind of graph is that? Starts with an L. Linear. It's a linear graph, right? It's just a line, has a y-intercept of, and a slope of 2, right? So it starts at 3 and then it goes up to over 1. So that's a line, and then it's got a piece of this other. What is that? That's a parabola. And so we're going to talk about how to evaluate and how to graph these piecewise functions, okay? And then how to look at the domain and range of them. All right, first of all, let's do some evaluating. What if I asked you to find f of 2? But every x equals 2, but I've got 2 different equations here. So my question is, how do I know which one to use? Which one do I plug into? I can only have one answer. All right, you say the first one. Why do you think the first one? Guessing? Okay. It's actually not the first one, but all right, so if I tell you that I have to plug into the second one, can you guess why? X is greater than 0. You're exactly right. Remember, it's f of x. This x is 2. Is 2 less than 0 or bigger than 0? Bigger. That tells me this is the equation I need to use. Does that make sense? So f of 2 here would be 2 squared minus 1, which is, before you tell me the answer, 3. So just write 3. How about f of negative 2? I'm going to the other equation, right? Because 2 is smaller than 0. So I'm in that first equation. So I have 2 times negative 2 plus 3, which would give me negative 1. Nice job. What if I asked you f of 0? Why? Look at y'all. I tried to trick you. Top one because it's or equal to, so it's 2 times 0 plus 3, which is 3. Everybody okay there? Good? No? Yes. My problem's gonna be these boys right here in it. Keep them straight. Keep them straight. Let's do another one. No, we don't undress in here, Kevin. We stay completely dressed. All right, take a look at this one. This one looks a little bit different. Huh? Yeah. Why? Can't learn if we don't change it up a little bit. I do, but do you? Yes. F of 0. Which equation am I using? That's right, the first one, because 0 is smaller than 2, right? So I would plug in, this would be negative 2 times 0 plus 1, which is 1. That's right. What if I asked you to find f of 10? Wait. Let y'all do it. That's the bottom one because 10 is bigger than 5, so I get 10 squared, which is one more. Because 3 falls between 2 and 5, right? So I get 3 plus 5, which is 8. Everybody okay? Okay. Brian. Yeah, so I'll give you what's in green and then I'll ask you these. All right, let's get to the hard part. Y'all ready for the hard part? Let's start easy. We're just picking linear today. All right. Here's what you have to understand. You have to understand how to graph the whole function, and then we have to understand how this restriction works. Okay. So first things first, let's just look at this first equation. And I'm going to show you 2 different ways to graph this. You can pick whichever way you like. I'll tell you what my favorite way to graph it is. But I think the easiest to understand is if I show you my least favorite first. And I call this the eraser method, okay, because I'm going to do the whole thing and then erase what doesn't apply. So for this, if I were to graph this equation, tell me what that would look like. It's a line. How do you graph a line without a calculator? Come on, y'all. It's in slope intercept. Draw it how? The y-intercept first. The y-intercept is what? 1. So I put a point at 1, and then I do what? Oh my goodness, y'all. Lines, lines, lines. Start at the y-intercept, and then do the what? Rise over run. That's exactly right. It's just 1, which means I go up 1, over 1. And so that's exactly right. So here's my line. Does everybody agree that's the line y equals x plus 1? Oh, it is, Caleb, it is. It is. Just agree. What? Is he being ugly? Are you being ugly? Were you being ugly, man? Were you being ugly? Oh my God. Okay. This is the line, yes? That's the whole line. You did that back Algebra 1, 8th grade, right? We graph lines. But now what we're doing is we're cutting this line off and we're saying, okay, that's the equation, but only when x is smaller than -2. So what I need to do is say, okay, well, where is x -2? It's -2 right here, right? And let me draw some more. Let me get this line to keep going. So what I'm saying with this is I'm saying at -2, I want to cut this off. And I only want one side of it. So I have to decide, but what side do I want? Is that when x is less than -2? I want the left side, right? I want all of this to be the graph I keep, and I want all of this gone. So what I'm going to do, this is why I call it the eraser method, is I'm going to come in with my eraser, and I am literally going to erase that part of it. I know I didn't need to. So from -2, I only want the part that's less than x. Now, the next thing I have to determine is at -2, does it include -2 or does it not include -2? It does include. So if it does include, so if I'm like this, just like on a number line, I'm a solid dot. But if it's not included, I'm going to do an open dot. Okay? So right here at -2, where this line is, I'm going to put a closed dot. Nobody does. Sorry. All right, let's do the next one. And I think I'll do the next one the other way because this way's messy. I hate messy. The next way is a little bit easier. I call it the plug-in method because we know where we're cutting off, right? We're cutting off when x is -2. So what I'm going to do for this one, I'm going to take this and I'm going to plug it in here. When x is -2, think about like a t-chart. When x is -2, what is the y value there? 2 times -2 minus 1, -5. We all agree? Is that going to be an open or a closed dot? Open. Why is it open? There's no line under it. So I'm going to go -2, -5, -2, 1, 2, 3, 4, 5. And I'm going to do an open dot right there. Now what I do is I pick an x that satisfies this requirement. By satisfies that requirement, I mean an x that's bigger than 2. So give me an x that's greater than 2. Oh my gosh, 3. No, let's stick close though. Let's stick close. 3 would work. I'm gonna do -1. Y'all are getting way far away. I want to stick close. It's not wrong. If you pick 7, if you pick 3, just remember you're going to have to graph whatever you get. Okay, so I always like to stick close if you don't have to. All right, if you plug in -1, what do you get? 2 times -1 minus 1, -3. Okay, so that's -1, 1, 2, -3. There's that piece of that line. Okay, that's what a piecewise graph looks like. 2 lines, and we're only dealing with linear today. We're going to just stick with linear until you get the hang of it. But that's 2 pieces of 2 different lines. Does that make sense? Okay, let's pick it up then. What is the domain here? You have to look at them overall as a whole. So left to right, what's the furthest left it goes? -infinity. As I move to the right, okay, so here's how I do this. I'm looking at this graph, right? Here. Well, I'm still in domain right now. So what's my domain? -infinity to positive infinity. There's no time where I don't have a graph for x there. How about the range? That's from the bottom up. So lowest the graph ever goes is what? Okay. Is this -infinity up to positive infinity? That's exactly right. Okay, sir? All right, here's what I want to do. I'm actually going to give you your homework because I want to work through one of these with you. Actually, no, because you only have 8. Let me do one that's not on here. You can still move. I don't think All right, I got 3 different equations here, and I'm going to graph this. I'm going to do one more example with you before you can just leave them on the table. Yeah. That's just like we did in the beginning. I will say if you understand and you're jumping ahead, that's fine. I've set up Khan Academy for this lesson, but I don't have it for the rest of the unit. I'll have the rest of the unit done by today. I just haven't had a chance to finish it. So don't get behind on that like some of you did on the last one and have to stay up all night the night before the test to get it done. I don't know. I haven't decided how I'm weighting it quite yet. Uh, I did take some off the other one, and I didn't do. So there's 6 things that go with. There's 6 things. Well, you can probably do them all after I take them off. But oh, you had already done them all. I did. Yeah. So there's like 6 things that go with Piecewise instead of like 15. Get 100%. I got everybody's percentage. I printed it out yesterday. I don't know what I'm gonna do. Well, I got to do it for some accountability too, not just extra credit. We'll see. I'll see. I'll let you know. All right, let's look at this. I really want to see how the test grades correspond to the percentage you got done on Khan Academy too. Anyway, all right. Tell me this. If I have just y equals a number, y equals 5, what does that look like on a graph? Students always struggle with this. What does the line, no, this one's not on it. What's the line y equals 5 look like? Just a horizontal line, right? It just at 5, 1, 2, 3, 4, 5, it goes straight across, right? And this is saying, now if I look at the restriction, if I know that and I look at the restriction, that's saying when x is less than -1, I'm cutting it off at -1 and I'm just including this part. I just want y'all to understand where this was coming from, okay? So when I start talking about plugging in the restriction first, if I plug in -1, if I think about a t-chart, it doesn't matter what I plug in, right? If I plug in -1, I'm still going to get what for y? Y is always 5. If I pick an x less than -1, give me an x less than -1. -2. What's y? Come on, y'all can do this. 5. It's not a trick question. It's always 5. For this first one, no matter what I plug in this equation, it's going to be 5. So this is what it looks like on the graph. And this is on your homework, and that's why I wanted to go over one like this. 1, 2, 3, 4, 5. All right, so at -1, am I open or closed dot? Open. Why am I open? There's no line under it. That's an open dot. So -1, 5 is an open dot. And then -2, 5, this is what this line looks like. That's that piece of the line. Does that make sense? Just like up here, see where I cut it off, but I included that. That's all I have here. These to me are always a little bit easier than the others because I got 2 points to plug in. I just plug in the 2 points that are given. Now here's the only thing. This is going to be a closed dot, but what's up with the second one? Open. Everybody see why? Yep. So if I plug in -1, what do I get for y? If you plug -1 here, if I said what is f of -1? 1/2 times -1 plus 3, close. This is -1/2, this, but it's not negative, it's positive, right? So 2.5. Now I'm also going to plug in the other end. So what happens if I plug in 2? What do you get? 4. Because 1/2 times 2 plus 3 is 1 plus 3, which is 4. So these 2 points, -1, 1, 2, and 1/2, and that's closed. And then 1, 2, 1, 2, 3, 4, and this one is open. There's my piece for this one. Does that make sense? Y'all see what I'm doing here? It doesn't go forever because this time it says stay between -1 and 2. Just stay sandwiched between those two numbers. That's where I'm cutting off. How about this last one? What am I going to start with plugging in? 2, because that's my restriction, right? If I plug in 2, what do I get for x? -4. That's a closed dot, so 2, 1, 2, 3, 4. And I need one more point. What should I plug in? 3? Bigger than 2, because it says greater than 2. What do you get if you plug in 3? -6. That make sense? Everything on the line is closed. Only your starting points or endpoints are going to be open. But everything that you use to graph is besides that closed. I can help you start number 3. And it may help you to use a pencil and do the eraser method until you fully get it, but whichever way you understand it best, it doesn't matter. I'll go ahead and plug in since that's the way I've been doing. If I plug in the restriction that's given, I got -3. What do I get back out? What's the y? In other words, what is f of -3? -3. So this point is -3, -3. Is it open or closed? It's closed. Okay. Now I need another point. What point am I going to pick? 1. It's less than -3. This tells me pick -3 and then pick one less than -3. So less than -3, maybe -4. And if I plug in -4, what do I get back out? -4. So -4, -4. This is my cutoff, right? So this is the side that I want. So you have to look at this restriction. It says I want everything that's less than -3. So 1, 2, 3. So this is my -3, right? This is my cutoff. I want everything smaller than that, and smaller goes in this direction. Yeah. How about the second equation? What am I going to plug in? -3. When I plug in -3, what do I get back out? -2 times -3 plus 1, which is 7. So I've got -3, 1, 2, 3, and then up to 7. Open or closed? This time it's open because there's no line under, right? All right, now I need another point. What x am I going to pick this time? Maybe -2. Pick -2 because that's bigger than -3, right? And that's what it's telling me. Pick an x bigger than -3. So if I pick -2 and I plug that in, what do you get? The only thing that's possibly open is the very first point. Other than that, everything's closed. What is your domain? What about the range? Yes. How did you get that? So it goes down forever, right? That's my negative infinity. And then as I start making my way up, I go up, 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 up. Well, it looks like this one stops, but this one's still coming down, right? Because it goes on forever. So I got a piece of graph there, come up, 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 up. But I dead stop here. There's not any more graph, and there never is. Since range is y, that y value is 7. Do I need a bracket or a parenthesis? Sure. Why is it? It's parenthesis because it's open. Exactly. This is hard. We'll do this today and tomorrow. You don't think it's hard? Good.